Okay, uh, let's have a closer look at the rate equation. Okay, so this could be for a reaction A plus B going to C. Right, the rate, that should always be measured in moles per decimeter cubed per second. So rate of change of concentration with time. This is called the rate constant, and that doesn't change as long as the temperature stays the same. Right, and these two, X and Y, these are the individual orders, reaction orders, with respect to X and with respect to Y. And then something we're going to talk about now, which I briefly mentioned before, is the overall order is the sum of the individual reaction orders. So it's equal to X plus Y. That's what the overall order of the reaction is. Now we need to have a think about what are the units of the rate constant going to be. Okay, so let's consider a reaction. It's going to change depending on the form of the rate equation. So let's have rate is equal to K. Let's say we've got A to the power of 1 and B is independent of B, so B to the power of 0. So it's zero order with respect to B. So in actual fact, we don't really need to put that in the equation. That could be left out. Okay, so we do the normal thing. Let's rearrange to get. We want to find out the units of K, so let's rearrange to get K. K is equal to rate divided by the concentration of A to the power of 1. Right, the units of K must be the same as the units of this thing. Okay, so what's the units of rate over A? Well, it's going to be rate is always moles per decimeter cubed per second. And the concentration of A is mole per decimeter cubed. So that's quite easy, isn't it? Those two are going to cancel out. So the units are going to be just S to the minus 1. So what kind of a reaction have we got here? This is a first order reaction, isn't it? First order overall, because we just got that 1 there. 1 plus 0 is equal to 1. And so if you get a first order reaction, we'll do a summary here. So order, overall order. Myself a bit more room. Overall order. And the units of K. So we've got, I'm going to leave a gap there for a zero order because we haven't done that yet. First order, the units are just going to be seconds to the minus 1. Okay, let's do it now if we've got a second order reaction. I'll get rid of that. So a second order reaction, rate is equal to K, A to the 1, B to the 1, so 1 plus 1 makes 2, or I could have just rate is equal to A squared. Yeah, that would also be a second order, it wouldn't make any difference. So what are the units rearranged to get K? K is rate over A to the 1, B to the 1. So it's going to be units of rate of reaction always mole per decimeter cubed per second. And we're going to have mole per decimeter cubed on the bottom, multiplied by mole per decimeter cubed because the concentration of A and the concentration of B. So what will happen there is one of those mole per decimeter cubed is going to cancel out. Seconds to the minus 1 over mole dm to the minus 3. We've got to put it all on one line, so the mole dm to the minus 3 comes up. So we change the indices there. Remember your indices rules. Second to the minus 1, that becomes mole to the minus 1, and that minus 3 is going to become a plus 3. So it's going to be that. So there, the overall is second order. The units are going to be second to the minus 1, mole to the minus 1, dm cubed. Let's do a third order overall. So all I have to do there is just change a few things here. So I'm going to write it all out again. I'll put a 2 in there. That would be third order, wouldn't it? And I'd have to change, or you could have it A. Yeah, we could have that. So I'm going to have to change that. I'll put a 2 there, and I'll rub this out now, I think. We'll do this. Okay, so the units of K are going to be the same as the units of this thing here. Let's do that. So we're going to get mole per decimeter cubed per second on the top. And then we're going to have mole per decimeter cubed times mole per decimeter cubed times mole per decimeter cubed. We can cancel out one of that lot, can't we? So get rid of that and that. So that's equal to second to the minus 1. And now I'm going to multiply this out, this bottom bit. So that's going to be mole squared. Remember indices rules, times it. When times these indices, minus 3 and minus 3, you add them together. So it's dm to the minus 6. Now we need to get that up onto the top line. So it's going to be s to the minus 1, mole to the minus 2, dm to the plus 6. So I put that there. 3, second to the minus 1, mole to the minus 2, dm to the plus 6. Now, if we did a fourth order, which I'm not even going to work it out, but you can tell what it would be. You just follow the pattern. Mole to the minus 3 this time, and it would not be dm to the 3, 6, but to dm to the 9, wouldn't it? And if we carry on with that pattern there, we should get, so what we're doing with mole number there, that's getting, as we're going minus 3, minus 2, minus 1, naught. So here it should be 1, shouldn't it? You see the pattern? So there it should be s to the minus 1, mole to the plus 1, dm. Now what do we do with the dm? It goes 9, 6, 3, 0. So that's going to be minus 3. And we'll just check that 0 order. This is called the 0 order. So I just get rid of that. We'll just check that's right. We're going to have rate is equal to k, a to the power of 0, and if you like b to the power of 0, it doesn't matter about the concentration, so they're just going to go. So k is going to have the same units as rate, which is, of course, the units of that are mole per decimeter cubed per second, which is what we said we'd get up there. Doesn't matter what order you put them in, of course. Okay, so that's just working out the units of reaction, the units of the reaction constant k, and how it depends upon the form of the race equation. Right, you get a lot of these number crunching questions here. Now they tell us the rate equation here. Look, it's rate is equal to k c squared d to the power of 1. So we want, first of all, we can work out what k is. And then what we can do, we can use k to find this. To find this initial rate. Okay, so they're changing the concentrations of C, changing the concentrations of B. So let's rearrange that to get K. So K is equal to rate C squared times D. So using the experiment 4 line, we'll put those numbers in there. So it's 7.2 times 10 to the minus 4 over 1.9 times 10 to the minus 2 squared, multiplied by 3.5 times 10 to the minus 2. All right, do that in a calculator. What do we get? Right, if you do that, you get 56.98, but we need to be careful of significant figures there. They're only given to two significant figures, so we should call that 57. And the units, well, overall, we can see it's a third order reaction. So as we said earlier, the units are seconds to the -1. It's third order, moles to the -2, dm to the 6. That would be the answer there. And then to work out the initial rate, I'm not going to do it. You can do it if you like, but all you've got to do is put your numbers in. So into this equation here, using the values for 5, and you know the value for k because you've just worked that out. Okay, so those sort of questions are not that difficult really.